Hello, everybody. We're going to get started now. First of all, thanks to everybody for joining. I'm excited about this talk. We launched a product called CockroachDB Serverless about a month ago and have enjoyed some incredible interest in that product. I think thousands of clusters have been created, and today we're going to dive into the architecture of what we built and get into some of the details of kind of what's under the covers there. If you have already created a CockroachDB serverless cluster, thank you so much. But again, thank you for being on this presentation today. So quick housekeeping. Please do ask questions in the QA panel. We love questions. We love chat. If you want to ask in the chat is great as well. If you're tuning in online, you're on YouTube or LinkedIn, we're monitoring those channels as well. So I believe there is a vehicle to add questions there as well. So please, gosh, by all means, add questions there. I'm happy to take them along the way. I'll be monitoring the QA in the chat, but I'm also joined by my friend Tim Vale, who's going to be on that channel as well. So first of all, I'm Jim. I'm Jim Walker. I'm Principal Product Evangelist. I'm an ex-engineer, and on Twitter, I am James. Now, this session is intermediate. People like for us to actually, tell them kind of what level of detail this is going to be. Now, that said, I'm not a database expert, but I work with a whole lot of them. And, some of the work that's been done to push forward CockroachDB Serverless is just truly phenomenal. I am a student of a lot of the work that happens here at Cockroach Labs, and I really think this stuff is cool. But I will tell you, when I first kind of got introduced to serverless, it's a couple of years ago, I still was kind of doubtful of the whole kind of concept. But the deeper and deeper I got into thinking about this and the concept of a database, the more and more I became a believer in serverless. And I think, hopefully I show you some of those concepts here today. So, and again, please do ask questions. So I will come on video so that you can see as I speak as well. Okay, so let's get into it. So let's just start talking about serverless. Serverless as a concept really is kind of a paradigm, if you will, that allows you to kind of build and run applications without thinking about servers. Now, I like to extend this beyond servers. I think it should be infrastructure. I think it actually should be called infrastructureless. I think if we're going to abstract away the concept of a server and kind of how we manage and maintain those things, shouldn't we actually get beyond that into load balancers and regions and AZs and all this other stuff that actually goes into deploying our applications? I think eventually that's what this becomes. I think serverless is absolutely an apt name, although it's a bit of a misnomer because there are a lot of servers in the background of a serverless compute platform, right? And so the computing paradigm really kind of states little to no server management, automated elastic scale. It needs to be resilient, fault tolerant, always on and available. It needs to be instant, even if it lies dormant for a minute, it needs to come back very quickly. And then ultimately, I think the thing that I think is most interesting, from my opinion, about serverless is just whole consumption based, and being able to only paying for what you use in the context of what you actually go out and deploy. Now, over the past 5 years or so, this execution model has been used in a couple different ways. I love the serverless compute platforms. I was on a live stream last week with my friend Preston Holmes from Google, who's a product manager on the Google Cloud Run team. What a beautiful, elegant, platform that is to deploy, containerized applications. Take any containerized application and go deploy on Google Run and just kind of void yourself from worrying about backend services and all the backend technology to actually scale those things. Truly tremendous. It was a very interesting live stream with a great demo I think Preston gave for about 20 minutes, but it really showed the power of the serverless compute platform. Now, we like doing things with other serverless compute platforms because actually doing serverless compute with a serverless database starts to make a whole lot of sense. And there was definitely an angle there, but I think Google Cloud Run is pretty cool. Serverless functions I also find to be pretty interesting. There's lots of them. I think AWS has really led the way with Lambda and what they've done there. Truly phenomenal. I also not listed here as kind of Netlify and their approach. I think working it into the developer workflow, I think it's tremendous, right? And it's pretty simple. So I think there's lots of ways serverless is being used today. Now, what we've done is we've basically taken the serverless principles and those concepts and applied it to the database. And And if you think about data, data actually creates significant challenges in the context of serverless. Because in the context of serverless, you need to scale up and scale down. You need to scale to zero because if there's a dormant cluster. Well, the problem with data and in your applications, as you think about them as well, is this persistence of data when things come back. How do I preserve state in whatever it was that's scaling up and scaling down, or translate that state into other places? For us in a database, I mean, that's a huge piece of it. It's everything what a database is, right? We're going to store that, right? And so how do you actually take care of those sort of things? And I think data creates a pretty heavy ripple in kind of going out there and actually applying serverless principles. And I think that applies both in what we're doing here as a database, but possibly in what you're doing if you're going out and using serverless in a sort of form or fact, in any sort of form. Auto scaling a database is also a bit of a challenge with kind of legacy databases. I think the distributed databases, something like a CockroachDB, being able to auto scale is a big deal. I think this is one of the reasons why a lot of people using kind of serverless compute have kind of turned towards these NoSQL databases like Dynamo and others, because of this auto scaling capability, because it kind of aligns very well with that. Well, why not use that, but get relational as well and get, transactions and simplify your development process, right? I think that's kind of a big piece of this. And ultimately, I think if you start to think about databases and scale, and what does that mean? Scale of volume of the data, scale of transactions, but geographic scale presents significant issues when we start to really get into the world of serverless. And I think if we're going to be serverless, should serverless be contained to a single region? Or does serverless actually translate to multiple regions and across the globe? Our vision is that's across the globe, and I think that's kind of one of those things over the next 5 to 10 years. I would love to see solved, not just within the concept of the database, and I'll show you kind of some of the stuff we're doing there, but really in the general concept of serverless. So when I think about serverless, it's some principles. I think people use it in some tools. And then serverless database takes those principles and applies it to the database. That's kind of the way that we think about these things. Now, we built CockroachDB Serverless really kind of as a result of two major shifts that we're seeing. Number one, it's pretty much every net new workload that we're seeing is landing in a cloud service. Number one, the adoption of CockroachDB Dedicated has just been phenomenal since we introduced that a couple of years ago. But on the other side, and this is obvious to many, not to all, developers make decisions, and especially around the database. When you start coding, you go choose a database, you spin it up, and you start using it. And really, developers have a very discerning palette. They know what they want. They want it to have low to no friction. No friction better. It should be instant. It should be easy. They want to code against an API. Look at the movement around Okta and Auth0 and Twilio, and this whole movement towards kind of API-based development is huge, but they absolutely don't want to deal with operations. I don't know a developer out there who says, yes, I would like to actually manage my database or manage any backend infrastructure. They just want to code and build. And then the third concept is, they want to start free, but pay for what they consume. And this is kind of this freedom. And I think this concept of a generous free tier is something that companies who get developers are really kind of pushing forward with. I think about like the free tier for, again, I go back to Netlify. I love what they're doing. These sort of things, and paying for what you consume is a critical part of that, right? And so I think we look at this net new workloads going to the cloud. Developers make decisions has really resulted in us basically taking a step back and saying, look at what we've built thus far can scale. What we've built thus far is resilient. We have solved the problem of transactions at global scale, right? And we are guaranteeing consistency. All the while, CockroachDB is implemented with familiar SQL. We chose, Postgres as the to be wire compatible with Postgres, and this is just SQL, right? So this is just the relational model. And so, for years we've been building CockroachDB, almost 7 now, and we think we built a phenomenal, interesting database, and it is. To us, what we feel is kind of that next generation cloud database, really built for this next generation infrastructure. So we took a step back, we looked at what we had, and we said, how do we extend that to actually make this serverless? And we took the principles and we laid it over CockroachDB. And we said, great, we need to build automated elastic scale. So scale of both volume of data and transactions up and down. Automating resilience so that I can survive the failure of an AZ for if an AZ goes out, I'm not going to lose data. Well, that's kind of core part and parcel of what we do. And in CockroachDB, but how do we automate that, right? We had to add consumption-based billing, right? So that you only pay for what you use. But if we're going to do that, we had to actually allow for dormant clusters to be created. Well, not created, but if a cluster scales down to no traffic, it needs to be turned off. We need instant starts, but most importantly, this needed to be multi-tenancy. So what we've built is one single database that is hosting multiple different tenants. So the thousands of clusters is all running really on kind of one instance of Cockroach database. And I'll show you how that architecture works. And that's really what this talk is about today. We're going to show you how we actually accomplish these 6 concepts in the database a little bit later in the conversation. But before we go there, I have to kind of, one last slide before in the whole setup. Again, we built this for developers because developers don't want to deal with operations. They want to start instantly. They don't want to deal with ops. They want to automate scale, and they want to eliminate downtime. We want developers to just go out and build and make it as simple as possible to focus on code and not the back-end operations. So let's get into the architecture. I jumped the gun. I was one slide early, but again, this is, I think, the second time I've ever presented this. So stick with me, y'all. Thank you. All right, so databases. Databases are really comprised of 3 layers if you kind of like think about them kind of at an academic level. There is storage, there is an execution layer, and there is language, right? Because ultimately it's going to speak some language. SQL, I prefer. Storage because, well, you have to store it at disk, right? That's a big deal. And then in the middle, there's this kind of SQL execution, which is how does a query get actually executed in that database, right? And that's any database has those kind of 3 layers. Now, at Cockroach, we do it a little bit differently because we are distributed. So we had to kind of rethink the database. And when I think about kind of modern cloud infrastructure and what's the right approach to thinking about a database, working this concept of being distributed throughout every layer is really critical. I mean, even in the language to actually control the database and how you think about, querying database in a distributed environment, even in the language, you have to start thinking distributed and do some modifications to the language to accommodate really the underlying infrastructure of how we execute, how we distribute data, how we store data in this environment. There's some other databases out there. Maybe they choose to, make one piece of this layer distributed. To me, that's not distributed SQL. I think the distributed notion really is kind of top to bottom throughout the entirety of the database, and really re-architecting from the ground up is really what we felt was necessary, honestly, to really kind of take advantage of this. And so let's use this as the paradigm to actually go through how we built serverless. And I'm going to outline some of the changes we made in our core basic, in our foundational CockroachDB to actually make this serverless. So we'll use this as our framework here as part of the conversation. So first of all, yes, we are wire compatible with Postgres. This is a relational database. You get referential integrity, there's normalization, there's secondary indexes, all the things that you love about the relational data model, that's what you have here. And I feel this is important because as you go forward with serverless, and maybe it's serverless, compute and the serverless functions, decreasing the complexity, I think, is pretty important. And using a relational database actually does decrease complexity. It also allows you kind of this nimble nature of doing things like online schema changes and this sort of thing, right? And so I just feel that decreasing complexity and enabling more agility as you go forth with serverless, I feel this is actually pretty important. So I think if you're using serverless computing, using a serverless database and relational at that, I think is a really, really good fit. So I start here just with that in mind. So let's go down to the storage layer. And I think I like to start there when I talk about the architecture of Cockroach database, because, this is the stuff that actually started to make, help me understand kind of how Cockroach was special. And really kind of starts at the way that we store data to disk. And so Cockroach database is exposed as a relational database to everybody who uses it. Now, under the covers, in our development teams, and what we're actually doing when we actually interact with block storage and what we're doing underneath, ultimately every table that gets exposed as relational is written using a KV store. And this KV store is something, it's called Pebble. It's actually, we used to use something called Rocks, but we actually rewrote it in Go and named that Pebble. Now, every table in Cockroach database, when it is stored, is really stored using this kind of monolithic KV space. So all of the records are kind of in order based on the key value in this thing. And so ultimately, it gives us some really, really powerful functions really at that lower layer, right? The primitives of get and put and how fast that is across, this block storage. And so ultimately, under the covers, we are a KV store. Now, all tables have a primary key, right? That are in CockroachDB from a relational point of view. And the KV pair that we actually implement in this table, and I'll show you in the next couple slides, it's just a combination of some information that talks about the table, the index, the key, and the column name, and then we point to a column value as the value. Now we do this, and I'll show you actually how this works over the next couple slides. But this is a critical kind of concept to actually understand in CockroachDB, and this is really what allows us to do some really special things around this distributed environment and how we use Raft and how we can do sharding and scale and resilience. It's actually the foundation of lots of things. So let's just make this real. If we create a table, and by the way, this concept and the next concept, I'm gonna show how we modify these. If you need deeper detail on how we actually do this, there's another architecture talk that's given, the architecture of a distributed SQL database, where we get into much more detail around how these things work. If anybody is interested in that, I know it's on our YouTube channel. So let's create a table. Let's load some rows to demonstrate this. So here we are. We're going to create this dogs table. It's going to have 3 columns: ID, name, and weight. And there's some entries over on the right-hand side. The key being the ID, so 34, 78, 94, and BC. Okay, so when we write these things to disk, right, we're actually going to convert it to KV and then write it over. So the first record is actually going to be kind of KV. Now, listen, the key is encoded into some special kind of format, so we can actually, sort through these very, very efficiently. But this is kind of a high-level understanding of this, right? And so here we have the table, the index, and the column name. And what we're going to do is write dog 34 name. The value is Carl. Weight 10.1. Downy 13.4. Figment 65.8. And then Jack 49.7. So what we're doing is we're writing all the values in this lexicographical form, right? Sorted by key. It's actually really, really important because I'm going to show how we actually use this to sort out the data into ranges in the next couple of slides. But so what did we have to do to make this multi-tenancy? This was our first problem. We have this database and we have this storage layer and we have a bunch of data that's going to be stored to that. So we want to make that multi-tenant. What we did is we just basically added to this K in the KV store a tenant to the key. So now what you see is here's a user, here's a tenant for our serverless database named Andy K, and we've now appended his name to the front of each of these keys. And so now when you sort this information in this huge, massive, KV store, you're going to see all the records for that particular tenant all grouped together and in lexicographical order still based on the subsequent values that are there. What this does is it allows us to kind of restrict secure access to ranges of data to an individual tenant, right? Because this tenant is mapped to these ranges now. And I'm going to show you how ranges work as well here in a little bit, right? So this table belongs to a tenant. And so we've made basically the storage layer, the KV store, we made how we do this multi-tenant. And so that was one of the key things that we did. And that's when I'm just doing a little check mark on the stuff that we wanted to actually talk through in terms of what we've done here. So that's number one. Okay, so now let's talk about how we replicate and distribute data. Again, this is a little bit of a refresher of how CockroachDB works. And it starts really at the bottom layer, right? This is a monolithic logical key space, everything that we store. And this key space is really divided into these contiguous 512 megabit ranges. Now you could think of a range as a shard or a tablet. There's other things, people call them lots of different things. Basically, it's a chunk of data. And remember, everything is ordered. Now, when we insert records, we can intelligently split tables and expand or reduce them back down, these ranges and whatnot. So there's lots of things that we can do here. Again, it's in a separate talk. I'm not going to get into that, but I did want to actually go through this concept of these ranges. So this table in particular is now broken down into 3 ranges, right? Carl down, it's the yellow, the blue, and the red. Now, if you actually do this, we had to actually create this index structure to locate these ranges. So it's very much like a B tree, if you're familiar with that algorithm. But in this case, you can imagine, well, these keys now are overloaded with a tenant. So the tenant has a set of index structures to locate the underlying data, because the underlying data is still going to be distributed across multiple different nodes in CockroachDB Serverless. It's just that storage cluster is going to be shared by lots of different individuals, right? Lots of different clusters, right? And I'll show you that in a diagram upcoming. Okay, so we also use Raft in this context. If you aren't familiar with Raft, great thing to go out and learn. It's a distributed consensus algorithm. I think once you understand Raft, a whole lot of things make a lot of sense in distributed systems. But really, Raft is implemented as a set of replicas, an odd number of replicas. So think about this range. I think this is the blue range. Think about the range as having 3 replicas of that data. Now, we get quite, even people ask us, oh, do you just synchronize data between one node to the next? No, we actually use Raft to actually write data to multiple different nodes and then get consensus around changes that we're going to make to that replica set, right? And so this replica set is really kind of the common ground in which we actually interact with data in Cockroach, and this distributed consensus algorithm is a key piece of that. Now, Raft is very chatty. It has coalesced heartbeats. It understands that if one of the replicas goes away because, say, a server failed, the remaining 2 will actually say, oh gosh, I need to get that data back. Raft also has a concept of a Raft leader. Oh, I'm sorry, they have to get it back. They have to recreate that, by the way. Raft also has a concept of a Raft leader. A leader is elected. So the 3 replicas get together and nominate one of the replicas to be a leader. And the leader is actually pretty important. They coordinate rights. And they always have kind of an authoritative, up-to-date understanding of what data is within that replica. So what those rows of data are in the KV store, right? Okay, so this also allows us to do atomic replication of commands. So we make sure that things are going to be right across all 3 replicas, which is a tremendous help in the way that we actually implement consistency in our database. We actually have serializable isolation in a relational database in distributed form. If you want to learn more about Raft, this is a great, I send lots of people to this website. So thesecretlivesofdata.com. If you go check that out, there's a really great description of how Raft works. It's a great protocol and definitely worth checking that out. It takes just a couple minutes. Okay. All right. So Raft is also used to, these replicas are then stored within physical nodes, right? So here we have the yellow range being stored on 3 nodes, the blue and the red, right? And so we're distributing this data across multiple different nodes. Now we distribute it in this form so that we can actually survive the failure of one of these nodes. We have 4 nodes. If one of the nodes fail, we have 2 copies of that data at all time. We're going to be able to survive this. We're doing this by default in CockroachDB Serverless, and I'll show you that. Now we can also write data based on, like, if there's a hot range, if one range is getting lots of access to it, maybe we isolate it on a node that has a lot of CPU present. We actually use this to geolocate data, so to tie data to a particular node or a region, if you will, in a multi-region implementation. Lots of different things here. So let's talk about now, how do we make this serverless? And this is a bit of a bigger challenge, because we had to get out of the context of the bits and bytes of how the database work and actually start to overlay that in how you implement the database, okay? So when we implement CockroachDB in a traditional CockroachDB implementation, what you do, this is a 3-node cluster, and we spin up 3 nodes. Here they are running on pods in Kubernetes, right? And they're all communicating, and they're really working as one single logical database, right? Any of these nodes can take a query. Every one of us is an endpoint. Every one of them can service reads and writes. And each node knows where to get the data underneath in the storage and replication, right? And it's distributed execution as well. So this is what we do in CockroachDB dedicated. We'll manage all this for you, but we're running it using Kubernetes. And we've learned a whole lot about Kubernetes over the past 2 years, deploying, again, thousands of clusters on Kubernetes as part of our managed service, CockroachDB dedicated. So that's the traditional way. So we took a step back and we said, okay, great. If we're going to make this serverless, we're fighting a couple of problems here. Number one, and as I noted up front, one of the biggest challenges with data is you don't want to actually spin up a cluster. Like if we just spun up a cluster and said, okay, this is going to be our serverless version, these things will live and die, they'll scale up, scale down. The problem is in the storage and replication. How do we actually persist data and come back to state when something wants to come back on? So the solution to this was basically, let's decouple execution from storage. And I think this is kind of a best practice of what's happening as people think about serverless in their applications, right? Take the execution and the storage, decouple them so that you can actually have this kind of always on storage and replication cluster, and then this kind of virtual or ephemeral pods that live on top of this, ephemeral SQL pods, right? So we teased out the storage and replication kind of code that was in Cockroach. And we've implemented this as a CockroachDB storage only cluster that we've implemented on the back end. The code to actually do all the other stuff is there. It's just kind of like turned off, right? All the SQL, and you don't interact directly with the storage and replication. And then we've basically taken out the SQL layer, execution, and distribution, and we've put that into a separate type of kind of instance of Cockroach. And we're going to deploy each of one of those on a SQL pod. That's going to service a customer. It can be ephemeral. They can die. They can come back. We can scale those. They don't have to rely on state other than whatever transaction they're working on in that moment. All of the state and all the data is actually in the CockroachDB storage only cluster down below. So really within CockroachDB Serverless, we have we have kind of two clusters, if you think about it, or many clusters, right? We have this storage cluster and then lots of virtual clusters on top for each tenant, if you think about that. Just SQL pods on top, okay? So first of all, that was kind of the first trick which we had to do to actually go out and do this, okay? So you can have multiple different tenants on top of this storage cluster. We have one storage cluster right now with thousands of tenants on it. And each of these tenants get assigned SQL pods. The first tenant has, 3 SQL pods. The second one just has one. They're just kicking the tires. They've just spun it up really quickly. The third one has 3 pods. And what we can do is we can scale up and down the number of SQL pods based on the amount of transactions that are coming through from that particular tenant, right? So this is how we can actually provide this elasticity. I'm going to show you that as well. Meanwhile, in the storage layer, we can expand as far as we want because we have this huge, massive storage only cluster underneath, right? And so this really allows us to do these two things separately and provide some of the value that we had talked about. So when we actually implement this, first of all, data is going to be guaranteed to be replicated across 3 different AZs. So underneath the covers, when we actually write data through CockroachDB Serverless, by default, you're going to get survivability of an availability zone. Currently today, CockroachDB Serverless is a single region database. We're working on making it multi-region. It's a big part of the work that we're doing here on the team. And then what does that mean from a survivability of data point of view? Those are the complications that, like I said, these are the things that get tough and are difficult challenges to solve in a serverless environment. Tenants get spun up, these SQL pods, they get spun up in random places across these 3 different availability zones. They don't need to have some sort of survival across an availability zone. And I'll show you why in a second, because ultimately we had to actually implement another kind of component here called a proxy. So we have these proxy pods. And really the job of a proxy pod is to basically route a query for a particular tenant to a pod that belongs to them. So you set up we have a load balancer that sits in front of CockroachDB Serverless, single IP address. What we're doing is we're sniffing each of the queries to say, oh, great, this query is for tenant number 1. Okay, I'm just going to route this randomly to one of the pods that belongs to tenant number 1. And now that tenant can now execute that query. It's going to coordinate with the storage layer underneath and actually execute that query. Okay, and so that's kind of the magic. And one of the big pieces which we had to go out and do is the proxy is necessary to kind of do this routing and trafficking to all these various different pods. Now, a proxy is also going to play another role in terms of scale as well, because scale in CockroachDB, really, we need to think about it in 2 ways. Number one, there's data volume, and data volume, well, the storage cluster takes care of that. We're going to measure the amount of scale and what you're doing down there, right? And so that we can scale crazy far on that side. But transactional scale is really quite different, right? We need to accommodate elastic use. So the amount of transactions maybe go up and down during the day. Maybe we have these huge spikes in traffic every day at 8 a.m. or something. How do you actually get more SQL pods so you can handle that transactional volume, right? And more importantly, how do we spin down to 0 so that if a cluster goes dormant, we aren't charging anybody. And honestly, so we don't get charged as well, right? Making this thing multi-tenant allows us to basically consume the least amount of compute we want to do, but more importantly, spinning down these clusters and the use of the CPU by each of these SQL pods, that also is what protects us from basically getting huge, massive costs on the back end. And that's one of the things that we've done actually, so that we can go out and provide a free database for everybody. And I'll show you about what's free in this in the next couple of slides, right? So this is all accomplished kind of using these kind of ephemeral SQL pods. Each of those SQL pods, like you think about like in Kubernetes and stateless, that is really the beauty of this, right? These things are ephemeral. All right, so what we built is an autoscaler. The autoscaler is basically going to monitor the CPU load for every one of those SQL pods. And it's going to calculate two things. Number one, the average CPU used over the last 5 minutes, and then peak CPU usage during those last 5 minutes, right? So average is going to give us a kind of steady state, the number of SQL pods we need to have deployed to meet that transactional volume. But then again, we also need to make sure that we're dealing with kind of peak moments in time as well. And so we use these two things to basically, spin up or spin down additional capacity, right? And that's what's really, really critical. And then also, if a load fails to zero, if the CPU load falls to zero, the autoscaler will decide to suspend that tenant as well, which means let's get rid of all those SQL pods. And so that's all automated on the back end, and part of what we built is CockroachDB Serverless. So let's just kind of show a little bit of how that works, right? So here we go. Here's our CockroachDB Serverless. I broke it down into one tenant, right? Now, in each of the availability zones, we have these things called hot pods, right? And that's what we call them, right? And so a hot pod is basically one of these SQL pods that's not assigned to any tenant, and they're just up and running, right? And what this allows us to do is, as we need to scale or we need to actually turn on a particular tenant, well, it allows us to basically get a pod up and running very quickly. So instead of having all this initialization time with Kubernetes and say, hey, spin up another thing, and we actually just have these things. The proxy just assigns a pod to a particular user, right? So here we have our steady state capacity. It's kind of in the middle. It's requiring 3 SQL pods here to actually service this traffic. And so at some point there's an increase in traffic. So over the past 5 minutes, we've had this massive increase. So here we are, we're going to take one of these unassigned pods over on the left-hand side in AZ1, and we're going to assign it to tenant 1. We're going to call it SQL pod 4. So now I've increased capacity, right? But at some point, capacity comes down to steady state again. So I've dealt with a spike and I've come down, right? And so now you're only getting charged for the compute that you use, right? You didn't have 4 instances up and running all the time in a traditional database. It's very different. Sometimes no traffic comes through. And so when this happened, the tenant goes dormant and the SQL pods spin down to 0. So with no capacity, there's no SQL pods here available, right? Now, one of the tricks with kind of these serverless compute platforms is how quickly they wake up. And so again, we're using this concept of a hot pod to basically, wake up a cluster again, if you will, so wake up tenant 1. So right now it's probably around a half a second to get that thing going. We're working really heavy to kind of break that down and really, really minimize the amount of time it takes to actually assign that SQL pod to the new tenant and get you going up and running, right? Because your application just sits. So that first query is always one of those concerns. So we do a lot of work there, right? First version is about a half a second. Probably it's pretty damn good, maybe a little bit lower than that. So, but we're doing lots of work there. So basically you can scale up and down based on load. And the auto scaler is basically understanding that all along and actually spinning things up and down for you. And that's how we actually get this kind of this elastic scale, right? Because I wanted to go through and explain kind of these 6 concepts, right? Automated elastic scale. The auto scale is dealing with that. We understand the CPU load for each particular tenant. We can actually deal with that. Surviving the failure of a particular AZ. Our ability to write data, the replicas using distributed consensus and Raft, right? Writing 3 replicas across these 3 AZs. You're always going to be guaranteed 2 or 3 of those are going to survive. And if an AZ fails for too long, we'll just create a copy in another AZ. But we're automating basically the placement of that data. Now, the consumption-based building is really kind of related to the next 3 items: spinning down to 0, getting things up and running in just a few seconds. That actually is a little bit off in the time. And then being multi-tenant, right? And we built a rating engine to actually make sure that, we're going to give you, a price at the end of the month that actually makes sense and is directly attributed to what you've actually used within the cluster itself, right? So let's talk about that a little bit. This is a pay for what you consume, never be surprised. So in CockroachDB Serverless, we have spend limits that are based on storage. So the number of rows that you have stored in the database. Now, remember, we're writing things in triplicate. We aren't charging you for writing things in triplicate. We only actually calculate the size of kind of the logical information of your database. So that what the the number of rows you have, not like not all the replicated data underneath. And then we also have this concept of a request unit, which is really just an abstraction of this transactional volume underneath and what your SQL pods are actually using from a compute network and IOPS point of view. Now, what's really interesting is if you look over in the UI, we also have implemented a spend limit. And the spend limit set at 0 just means that basically you're never going to get a bill. This will be free forever. We're going to throttle you to X amount of transaction, to X amount of usage, but it's going to be free. If you put in $5, you're never going to go over $5. 10, 50, whatever that is, it's a spend limit, and CockroachDB Serverless is smart enough to actually understand usage of your pods and what actually makes sense for the remainder of your month based on what you've actually used, right? And so it's kind of a key piece of what we're doing, and we're rating all this on the back end. Now you can start for free. This is a fairly generous free tier. We feel it's fairly generous. If not, gosh, engage us in our public Slack channel. We'd love to hear more. No credit card required. You could sign up with an email or your GitHub account. And we're providing to anybody, up to up to 5 gigabits of storage a month, and then 200 gigabytes of storage a month, and then 250 million request units. Now, a request unit is this 250 million request units is good enough for a fairly good size application with decent volume. In fact, we calculate about 100 RUs per second, so it's a decent amount of queries, and we'll publish more information about what size of those type of applications are over the next couple of months. This is a relatively new product. This is in beta. There's lots of work still being done here, but Banana, it works, I got to tell you. And then beyond that, if you want to actually go beyond these spend limits, it's $1 per additional gigabyte and then $1 per additional 10 million RUs. And it's really kind of a pay-as-you-go service. Now, what happens if I run out of these 250 million request units in a month? Well, the way I think about this is we've kind of given you a certain amount so that you're guaranteed a certain quality of service for the entirety of the month. If I think about the 250, it's kind of the space underneath the curve here, a derivative, if you will, right? And so if I use everything, like if you look at the last scenario, it's the easiest way to explain it. I use everything on day 1 or day 2. Well, we're going to guarantee you have at least 100 RUs per second for the remainder of the month. And it'll bank if you don't use those and those sort of things. And so there's some things there. I hope that helps helps explain some of those things. We get some questions there. We have lots of conversations about that in our Slack channel. So CockroachDB Serverless, the beta today, is really good for kind of like side projects, smaller apps. You're kind of building a prototype. Anyway, like not like super huge volume, but you actually do want to start building. I mean, this is wire compatible with Postgres. I used one of these low code platforms called Retool against CockroachDB Serverless. I had an app up and running in about 4 minutes. And with a little bit of volume published on the web, it was pretty easy. If you want to learn SQL, might be good there. And this is a full version of CockroachDB. No features are held back. This allows you to get familiarity with Cockroach Database. So this is just part of an overall product line for us. This kind of rounds out what we've been doing. CockroachDB Dedicated is really kind of this ideal experience for consuming CockroachDB. And these are dedicated instances in the cloud, right? You choose GCP or AWS. We provide all the SRE and manage that environment for you. Single cloud, multiple regions. Serverless is an emerging product of which is kind of consumption based, more kind of developer focused, and then self-hosted, our traditional version, which has been available for since the dawn of the company. Gives you really, really deep control, and you manage and can deploy across lots of different clouds and lots of things. So for us, if I think about CockroachDB and what we're building to, this is all about efficient operations. Let's let people build. Let's scale out writes for people. Let's give them instant clusters. Let's let you code against relational models, give you normalization, referential integrity, all these things. But let's not worry about scale. Let's not worry about operations. Let's ensure downtime and let's go cloud. And let's allow people to gain the efficiencies, massive, huge efficiencies of not having to deal with any of those things. And so, CockroachDB Serverless is a big part of this future for us. And I hope that was a valuable kind of run through of the architecture. So great. That is the rest. That is my presentation. I was not able to look at the questions along the way. Tim, are you still online?
I am still online, and I'm kind of furiously typing, not a terrible amount of questions, but there is one from Enrique, and I'll just read it out.
Okay.
I'm kind of working up an answer, so if we don't want to do it live, we don't have to. But essentially, kind of talking about, what is the security posture at the kind of at the storage layer, if you will, such
Yeah.
that we're properly isolating data from one tenant to another.
Yeah, I don't know if you have your version of this, Tim, but I mean, from what I understand, we authenticate each tenant against the storage layer, so that at the storage layer in the KV store, that tenant is part of the key. That's how we're isolating ranges between each particular tenant. Now, at the SQL pod layer, well, those are completely different processes, right? They are not connected at all, right? These are just separate pods that are running across these various different servers. So I know that's how we actually, segment off tenants at that layer. Do you have anything else on that, Tim? I know
Yeah, I think that's what I was going to say. I mean, I was looking at our frequently asked questions doc, and I think we attempt to answer this question, but not with maybe the level of detail we probably need. So I'm going to go back and make sure we kind of cover off on some of this. But no, I think at a high level, your answer is a correct one. We
Yeah.
really accomplished this by kind of stopping access at the SQL layer, which is single tenant, right?
Yeah. And the proxy is basically authenticating the tenants as well coming in. So, there's several different layers, and I'm pretty sure all data that's written in CockroachDB at the storage layer is encrypted at this point as well. So, there was a question. So, will it be a free tier extension when things go multi-region global? Absolutely, Steve. That is absolutely what we're building to. Like I said, we call this a beta right now because it is single region. That's one of the big reasons. But our vision for this is, let's have endpoints all over the planet, and let's just code against endpoints and never worry about the database. And so, we're building to that. I would expect, mid to late next year, there's a lot of complications in actually implementing a serverless database across multiple regions. I know the engineers are working on some really, and the product managers are really working on some heavy stuff there. So, Tim, anything else in this? Any other questions? Anybody in the crowd? We're happy to take questions, but so Tim, there is a question about what's the difference between distributed execution in the traditional CockroachDB implementation versus this implementation. Can you talk to that? I have some ideas here. Uh-oh, you still there? Am I not here?
I am still here. I started talking and I was on mute. Oh, and I'll come off video. So yes, I am a real person. Hello, everyone. In a lot of ways, they're the same. And I answered this question in the chat, right? I mean, distribution and execution, I think, was that the two terms, which in the traditional way we talk about layers of architecture, distribution and transactions, right? Those really are in effect the same, and they happen at the SQL layer before being routed to the distribution or to the storage layer. So I think that's kind of where we broke things apart in the serverless architecture. So my answer to this would be they're reasonably the same, at least at a high level.
Yeah. Here's another question, Tim. I'll dump this one on you.
Okay.
This is an easy one. Do you have any stats on performance on large loads compared to a column store database like Snowflake?
Well, Jason, I see this question, and here's how I would answer this. We're after the totally different type of workload, and that is true for Cockroach Cloud Dedicated or for serverless. So Snowflake, modern OLAP type solution going after analytical type workloads, right? Cockroach, regardless of the form it takes, is really focused on OLTP type workloads. So, do we have performance comparisons? No, because we see Snowflake is playing in an entirely different space. Having said that, Cockroach is making enormous strides, and again, regardless of how it's consumed, in OLAP light or analytical type queries. But our mission, vision, direction at the moment is focused pretty heavily on the OLTP market.
Yeah. Let's see. When you have a non-beta multi-region, will there be an option to use something like private links, so we could share the data we're operating with going 100% public in step one. So that's I don't know, Tim. I mean, that's looking forward about 6 to 8 months in the future, right?
Yeah, I think it's definitely on the roadmap. You know, moving serverless out of beta and allowing people to, you know, this will be part of that effort.
Right. Yeah. Yeah, there's a lot on the roadmap to get this thing from beta to GA, right? I think multi-region is one of them, Tim. You know, doing these sort of like implementations, allowing for, you know, this next question, which is like, yeah, I have a bunch of small shops which are geo-dispersed. Is each rooftop a tenant, or am I the tenant? I think, you know, Nicholas, great question. That's really going to be on what you're trying to solve. I mean, you can set up a cluster per particular app or particular tenant, whatever that is, but being able to manage things like that within CockroachDB Serverless is all stuff that we're working on. You know, really the regional distribution of data, that's the one that I think is a large challenge. Because as Tim said, you know, we've optimized our database for, you know, transactions and OLTP workloads. And doing that at scale across large regions is tough. And so I think that's the kind of stuff that's going to get us there. So let's see here, Tim. There was another question from Steve. I think the question was around security of the storage layer. Is around how do you protect bad actors from accessing the raw bytes? Actually, I'm pretty sure by default, Tim, is data written in is data encrypted, right, within each of the ranges?
Absolutely.
I presume that's how we protect that. It's default, right?
Mm-hmm.
Okay, great. I don't know. Is there any other question here, Tim? I'm just going through.
Are you using service mesh? Not that I'm aware of.
I don't think so. I don't think
mesh usage. I don't believe so.
I don't think we are. Yeah, somebody was asking, are you using service mesh? And so,
good questions in this one today.
I know.
Very
this morning
group.
we did this morning within the Europe time zone. We had some great questions along the way as well. So it's an interesting topic. I'm intrigued by it. So it's cool stuff. All right. Well, if there's no more questions. Oh, wait, there we go. Do you have a repo on your Retool app? I do not right now, Nicholas, but I'll surely publish my Retool / Cockroach Labs application for everybody to use. But Nicholas, if you want to go use Retool and get an application up and running, I would go use it. What was really cool about it is because we're wire compatible with Postgres, they have Postgres drivers. They don't have a CockroachDB connector. I just used the native Postgres stuff there, and I had an app up and running about 4 or 5 minutes. It was pretty cool. So I'm a fan of what's going on at Retool. Actually, it's some pretty cool stuff. So Tim, for government users, do you have any compliance with data protection requirements like that are in Canada, for instance, or for government entities?
Not at the moment. Certainly not in the serverless space. I know in the dedicated space, and some of these things will ultimately make their way into serverless. So we're working on some certifications that might be applicable here, but we should probably take that offline.
Yeah. And then are there any plans around integrating logging credentials with cloud temp credentials like IAM, Vault, VCC, so keys don't have to be rotated? So this is a pretty deep question. Steve seems pretty familiar with what we do.
Steve's on fire right now.
I know. Love Steve.
And that's great. Absolutely there are. Both in both, by the way, in kind of both mechanisms. So, there's some things we're doing related to keys on both the dedicated, the self-hosted, and certainly will be part of future serverless offerings.
And I believe there's a Jira ticket open on that one, Tim. I think somewhere. I've got to remember seeing that. So that's all out there in the open. So I'll try to find that for you, Steve. All right. Every time I say all right, Tim, a question comes through. So I'm just going to be more patient, or just keep saying all right. You mentioned that the underlying KV storage layer was RocksDB, and we rewrote it. Was there any improvement you noticed when you compared it to the open source C++ engine? Great question.
Yeah, I don't. Do you remember what? Because this was a little while back, and I know when we originally did it, and there's a great blog post on it, by the way. that Peter Mattis, one of our founders, did. And I know when we set out to do it, we were hoping the percent improvement was going to be quite large. I don't think it was as large as we expected, but there absolutely was an improvement, because we no longer, for those who don't pay attention to these things, when you have to kind of cross the go see barrier, there is a little bit of a performance hit. And so when we eliminated that, we did get some performance improvement. Again, I don't think it was as dramatic as we had originally hoped, but it was a good one. The other thing here, again, this kind of almost could deserve its own webinar, but the other thing is it greatly simplified our ability to support the underlying KV storage. ROX is this huge code base. We weren't using near enough of it to justify maintaining that level of complexity. So Pebble, which is the underlying KV storage engine that we replaced ROX with, it's a ROX compatible KV engine, is much smaller, purpose-built for the work that we're doing, much simpler for us to maintain because the code base is smaller, and it's written in Go, not C, which, as it turns out, we don't employ a lot of C developers.
Yep. And in that link that's in the chat, there's some diagrams and some stuff towards the end about performance characteristics of what we've done. So, and I think this was over a year ago now, wasn't it, Tim? I think it was 1 year ago. So September 15th, a year ago, we did this. So there's been massive improvements pretty much at every layer of the database since then as well. So, all
right, do your keyword again. Let's see if we get another one.
No, be patient and then say, okay, all right.
I don't think so.
All right. I think it was all right was the keyword. So.
All right.
All right. Well,
the question trigger.
Well, thanks, Tim. Appreciate it, buddy.
Amen.
As always, I haven't spoke to you on one of these things in a while, but
I know I haven't been on
thanks for
one of
helping
these.
out here. Really useful.
It's good to see the folks again.
Yeah. So, thanks for everybody for taking your time today. I hope this was valuable to you. I sincerely hope that I presented honorably for all the work that's gone into this. There's been some incredible engineering and product management that's gone into the build out of CockroachDB Serverless. I hope this basically helps describe some of that. There is a great blog post from us that actually outlines all of this in verbal form. If you're interested in that, it's one of the most recent blog posts on our website. Let me just pull this really quickly and get that into the chat as well. If somebody's interested in actually reading more about this, there we go. Where is this? Oh, here we go. How we built a forever free serverless database by Andy Kimball. Yeah, thank you, Steve, for all the questions. I really, really appreciate you joining. But if anybody wants to go check out more on how we built this, yeah, there's links to Raft, lots of stuff in here. We'd really appreciate it. But most importantly, if you could please take the post-event survey. We like to improve these things. Any and all feedback is extremely valuable to us. And just want to thank everybody for taking the time. Most importantly, Tim, thank you, buddy.